Alright, here in this problem, we're going to have a very interesting situation happen. So let's try and solve this to begin with. Okay, right now we have two factors that are equal to -9. But remember, our zero product property doesn't say anything about factors being equal to -9. It says factors equal to 0. So we're going to have to do something with this -9. This really has to be a 0. Well, we could move it over to the left first. So we would have x plus 3 times x minus 5. And then if I add 9 to both sides, it'd be plus 9 equals 0. Well, now we're equal to 0, but we no longer have only factors over on the left-hand side. So we're going to have to try and clean this up a bit. Let's go ahead and multiply everything out and put together like terms and see where that leads us. So if I multiply these two binomials, we'll have x times x is x squared. X times -5 would be minus 5x. And then distributing our 3 times x would be plus 3x. And 3 times -5 would be minus 15. That's multiplying out those binomials, and then we have plus 9 equals 0. Now if I collect like terms, we'll have x squared minus 5 plus 3 would be minus 2x. Minus 15 plus 9 would be minus 6 equals 0. Well, at least now this looks a little bit more familiar to us, because we have a polynomial equal to 0. Well, hopefully we can factor this down. So since this is a trinomial, let's put down our parentheses. So x times x would give us x squared. And now we have to think of factors of 6 that are somehow going to give us a 2 in the middle. So let's think of all of our factors of 6. That would be 1 times 6. That won't add or subtract to give us a 2. Then we have 2 times 3. But that adds to 5 and subtracts to give us a 1. And there are no other factors of 6. So this cannot be factored. This is not factorable. Now, I hate to say this way, because technically there is a solution, but we have not learned how to deal with problems yet that we haven't been able to factor. So in another section later on in the course, we're actually going to learn how to go about solving that. But for right now, if we can't factor it, then we're going to say there is no solution, just because this itself was not factorable.